Hello everyone, and today I'm going to be talking about the Euler's method. The Euler's method is to approximate the answer by using the step size so as to get a rough estimation instead of getting the actual answer. As you can see from this example, we can let a y equals to x squared, and we can let that step size which is 0.1 and the coordinates to be 1 and 1. As you can see, we let xn start from 1 and have increments of 0.1 all the way to 1.5. So to find yn, we can use the general formula on the top right hand corner, which is yn plus 1 equals to yn plus h, which is the step size, times f prime xn. Okay, so to find f prime or 1, we have to differentiate the equation of y equals to x squared, which equals to 2x. Moving on, we have to use this formula for all the way to 1.5 for xn. Okay, moving on, to get the actual answer, we have to sub in xn back into the equation of y equals to x squared to find y. As you can see, the actual answer is very close to yn. So as you can see from the graph below, I've plotted the coordinates of yn, which is, as you can see, very close to the actual, as it is a rough estimation to the actual number. Hence, by using a smaller step size, this would make our rough estimation to be nearly similar to the actual answer. We'll be solving the equation of dy over dx equals to x divided by y to the power of 2. And using the equation of y bracket 0 equals to 1. This means that y equals to 1 and x equals to 0. So using this Excel spreadsheet, you can see that when n is 0, x equals to 0, and then y equals to 1. And you can see from here that there's a step size of 0.1. Hence, to find y, we have to use our general equation, which is given yn plus 1 equals to yn plus h, which is the step size, f prime bracket xn comma yn. Okay, for example, to find y2, we have to sub in y1, which is 1, and sub h to be 0.1. Then for finding f prime bracket xn comma yn, we have to use the equation of dy over dx equals to x over y squared to and sub in x1, which equals to 0.1 to x, and y1, which equals to 1 into y squared. Hence, this gives us the answer of 1.01 for y2. Okay, from here we can use the general formula to calculate the rest of the other numbers here. To find the actual answer, we have to work backwards by using the differentiated equation and to integrate it back to get y equals to something. So from this, dy over dx equals to x over y squared. So from this, we have to integrate y squared, which equals to y cube over 3, and integrate x as well to get x squared over 2 plus c. C is basically the constant. So to find a constant, we have to sub in y equals to 1 and x equals to 0 into the equation, which gives us 1 over 3. So from this, we will have to make it so that we times the whole equation by 3, and then we cube root it so as to get y. Okay, from this, we can see that when x equals to 0.1, we can sub in it back into the equation of y equals to cube root 3x squared over 2 plus 1, which gives us 1.004, and when x equals to 0.2, it gives us 1.019, and when x equals to 0.3, it gives us 1.043, and when x is 0.4, it gives us 1.074, and when x is equals to 0.5, it gives us 1.111. So as you can see, the actual is very close to yn. Thank you for listening to this presentation.